So let us see an example for a log-based protocol, right? So again, we have a simplified banking system where we have two accounts, capital A and capital B. They are being accessed by the transactions T1. So in transaction T1, we are going to transfer $50 from account A to account B. Sorry, we are going to transfer $50 from account B to account A. And transaction T2, it is used to display the sum of total amount of money in accounts A and B, right? So you have two transactions. So the transaction system. So the first transaction is going to debit $50 from account B, and it's going to credit it into account A. And the second transaction, it is going to read the values of account A and account B, find the sum and display the sum, right? So now we are going to use log-based protocols for representing this transaction, right? So as you know that whenever you are going to perform both read and write operation on a particular data item, capital Q, you are expected to acquire an exclusive mode lock on the particular data item, capital Q, right? So in the first transaction, we are going to debit account B. So debit means you are going to both read the value of that particular data item, as well as you are going to debit or update the value of the particular data item. You are going to perform a write operation. So since it involves both read and write operation on a particular data item, capital B and capital A, we are going to acquire an exclusive mode lock on data item, capital B and capital A. So the first statement is going to be transaction T1 lock exclusive mode lock on data item, capital B, right? So we have an exclusive mode lock on the data item, capital B, since we are going to perform both read operation as well as write operation. So read of B, so you are going to read the values of the account B. B is equal to B minus 50, right? So using assignment operator, you are going to debit $50 from account B. You are going to write the value of the updated value of account B, and then you are going to, so once you perform both the read and write operation on the variable capital B, you are going to unlock the variable capital B, right? So the next instruction is that you are going to again you are going to perform read and write operation on the variable account variable A. So again you are going to acquire an exclusive mode lock on the account variable capital A. You are going to read the values of the variable capital A. You are going to credit $50 into account A, right? So then you are going to write the values, updated values of account A. Then you are going to unlock the variable A, right? So since we have done both, since we have to do some credit and debit operation, which involves reading a value and updating the value of the accounts B and A, we have done it using an exclusive mode lock, right? So whereas transaction T2, just you are going to read the values of accounts, account A and B, and you are going to display the sum, right? Since you are going to perform only read operation, we are going to use shared mode lock on the accounts A and B, right? So transaction T2, we are going to use only shared mode lock on the account, shared mode lock on the data item capital A and capital B. So initially you are going to acquire an shared mode lock on data item capital A. You are going to read the values of the variable capital A. Then once you read the value of the variable capital A, you are going to unlock it, and then you are going to acquire again a shared mode lock on the data item capital B. You are going to read the value of the data item capital B, followed by unlocking the variable capital B. So displaying the sum, right? So the initial values of accounts A and B are going to be $100 and $200 respectively. right? So if these two transactions are executed serially, either in the order T1 followed by T2 or T2 followed by T1, then the display, then the output will be then the final transaction will result, it will display the value as $300, right? So we started with using a log based protocol. So we have two types of logs, namely shared mode lock and exclusive mode lock, right? So whenever you need to perform both read and write operation on a particular data item, we need to go for exclusive mode lock. And whenever you want to perform only read mode operation on a particular data item, we are going to go for shared mode lock. And you all know that whenever the transactions T1 and T2 are executed serially one after another, databases is consistent. So the sum of the accounts A and B is going to be always same, right? So initially A value was 100 and B value was 200. So what will happen when T1 is executed followed by T2? So B value was 200, right? So B value is going to be 150, and A value was initially 100. So A value will be 150, right? So the sum of the accounts A and B is going to be 300. So the database consistency is preserved whenever you are going to go for a serial execution of the transaction. And let us see what happens when you are going to go for a concurrent execution of these transactions using log-based protocol. Right, so the two transactions are going to execute now concurrently, right? So the CPU time is being allocated between the transactions T1 and T2. So initially we are going to start with execution of the transaction T1. So exclusive mode lock is being granted to transaction T1 on data item capital B. So we are going to perform update operation on account or variable capital B. And once you perform debit operation on account capital B, we are going to release the exclusive mode lock. Now again we are going to, in the meantime, the second transaction is going to run concurrently. It is going to read the value of A. So what is the value of A? A value is going to be $100. So B value was initially $200. So now after this debit operation, it has read the value of B, and it is going to print the sum of accounts A and B. So it's going to be 100 plus 150. It's going to be $250, right? So when transaction T2 gets executed, it displays the sum of accounts A and B as $250, and then again transaction T1 is executed. So transaction T1, I think it should be A plus 50. Sorry, there's a mistake here. So it's going to be A plus 50. So it's going to be 100 plus 50, 150. So this, I think I have taken it only from your textbook. The thing is that the database is not consistent in this case because it displays the sum of accounts A and B as 250. Right. So if, however, these transactions are executed concurrently, in this case, the transaction T2 displays 250 as the sum of accounts A and B, which is incorrect. So the reason for this mistake is that this transaction T1 unlocked a data item too early, as a result of which T2 saw an inconsistent state. So what they say is that this unlock should be happened at the end of the transaction. We would have got the value of A and B as 300, right? So the transaction T1 has unlocked the data item too early, so which results in an inconsistent state of the database, right? So we'll continue in the next class. So next class we'll study what happens when we are going to unlock the particular transaction at the end of the transaction, and what do you mean by deadlock, how to check for a deadlock in concurrent execution of the transactions, and how to overcome deadlock deduction, deadlock prevention, right? So we'll study about deadlock prevention algorithm, deadlock avoidance, and deadlock detection algorithms, and how to recover the transactions from a deadlock state. Right. So we'll continue in the next class. So like us, uh, Saloni and Vishwanathan has given a nice introduction to XML. I would like you to practice XML, and this week I will have the same exercises, same questions, same thing. You can explore. You can check with. You can explore how to work with XML, how to perform storage, information storage, and retrieval in semi-structured data using XML documents. Right. So that's it for today's class. So any questions about today's class? So I hope that it's quite easy, right? So we'll meet in the next class. So thank you for your
Yes. Thank you,
participation.
sir.
Thank you.